Welcome to this explainer, where we're going to dive deep into a fascinating microscopic mystery. We are looking at exactly how your daytime behaviors dictate your nighttime cellular recovery. Today, we're exploring a unified biological framework, really connecting the dots between how you regulate your nervous system while you're awake, how that directly alters the architecture of your sleep, and ultimately, how it impacts your overall lifespan and longevity.
Right off the bat, we need to deconstruct a massive social media myth. You know the one, you've probably seen those viral claims floating around saying you can just hack your way out of severe sleep deprivation with a quick 20-minute breathing exercise. But when we actually look closely at the data, we uncover a very different story. Yes, both sleep and meditation do lower cortisol and calm the nervous system, but they are absolutely not interchangeable, not even close.
So here's the reality. Daytime mindfulness actually serves as a biological prerequisite. Think of it like cooling down a massive physiological engine so that deep rest can finally occur at night. It's a slow-acting medicine. If you try to use it as an emergency, in-the-moment sleep aid at 2 a.m., it's probably just going to frustrate you. Instead, regular daytime practice systematically shifts your baseline, laying down the biological groundwork for the deep restorative sleep that your cells are literally craving.
Let's move into Section 1, Waking Regulation and Shifting the Baseline. This right here brilliantly illustrates the biological tug-of-war happening inside our bodies every single day. On one side, you have the sympathetic nervous system. When this gets chronically activated by, say, a passive-aggressive work email or sitting in endless traffic, it triggers your fight-or-flight HPA axis. That leads to vasoconstriction and pumps your body full of elevated stress hormones. Now, on the other side is the parasympathetic nervous system. This is mediated largely by the vagus nerve and governs our rest and digest state. True sleep optimization requires us to consciously flip the switch, moving away from that threat-driven state and into the restorative parasympathetic dominance we need for recovery.
Let's dive into Section 2, Rewiring the Neural Architecture through Structural Neuroplasticity.
The data we're looking at charts out some truly incredible structural upgrades. We're talking about physical changes to your hardware. Consistent practice literally thickens the prefrontal cortex, which enhances our top-down executive control. It actually increases the volume of the hippocampus. Now that's a region incredibly vulnerable to stress-induced atrophy, yet it's absolutely essential for memory and contextual threat safety appraisal. At the same time, it decreases the reactivity of the amygdala, our brain's main alarm system. You are literally building a brain that is far more resilient to daily stress, which is exactly what prevents those late-night cortisol spikes from completely derailing your sleep cycles. But you know, this isn't just about what happens while your eyes are closed and you're actively relaxing. Research shows enhanced functional connectivity between the amygdala and the ventromedial prefrontal cortex. You can think of this connection as a top-down structural brake on your emotional hyperreactivity. The critical takeaway is that these structural changes transfer over to our ordinary, non-meditative states. That means you actively carry this reduced distress into the middle of a normal, chaotic, waking day.
All right, Section 3, Decoding Autonomic Balance and the Heart-Brain Connection.
By analyzing PhysioNet data, researchers looked really closely at the Autonomic Balance Index and respiratory sinus arrhythmia. Simply put, when you engage in slow, mindful breathing, your respiration and your heart rate synchronize beautifully. And this isn't some placebo effect. It triggers a profound, measurable increase in vagal tone. It proves that we can consciously control the fraction of our heart rate variability that is driven by our calming parasympathetic nervous system. As comprehensive meta-analyses spanning thousands of participants, by the way, confirm, stepping into this balanced autonomic state reliably drives down the biological markers of chronic stress. We see highly quantifiable drops in systemic cortisol, systolic blood pressure, and resting heart rate. By modulating these daytime metrics, we're effectively clearing out the physiological roadblocks, allowing the body to seamlessly transition into deep, restorative sleep architecture at night. Which brings us to a very important clinical caveat in Section 4, the window of tolerance and navigating trauma-sensitive mindfulness. So the window of tolerance is this optimal state of arousal where your nervous system can function effectively. But here is the biological catch we have to talk about. If a practitioner has unresolved trauma and they step outside this window, simply turning inward might not be relaxing at all. Actually, it could trigger a hyper-aroused threat response that does the exact opposite of promoting biological safety and sleep. This profound insight from Dr. Peter Levine really hits the nail on the head. It highlights that emotional and physical safety isn't just a nice feeling, it is a strict biological necessity for true nervous system regulation.
If the body doesn't fundamentally feel safe, it will not allow the parasympathetic nervous system to take over. And this is exactly why trauma-sensitive mindfulness doesn't ever force a single, rigid way to practice. Instead, it focuses on giving the individual total agency over their own internal exploration.
Clinicians employ these 4 steps, often called the 4 Rs, to maintain that crucial agency. It empowers individuals to gently apply the brakes. That might mean simply opening their eyes, shifting their posture, or changing the focus of their attention. Doing this keeps their nervous system securely anchored within that healing window of tolerance, ensuring that the pursuit of rest doesn't accidentally trigger a massive stress response.
Finally, let's zoom all the way in for Section 5, telomeres, cellular longevity, and the microscopic climax of this whole system.
18 months. This number represents the duration of the landmark Age Well trial. Researchers tracked older adults for a year and a half to see exactly how this specific intervention affected cellular aging. And what they discovered was absolutely striking. A high commitment to this practice creates a powerful protective effect on telomere length. It essentially buffers our cellular DNA against accelerated aging.
So here's the mechanism at play. Telomeres are the protective caps on the ends of our chromosomes, kind of like the plastic tips on your shoelaces. Chronic stress, elevated cortisol, and systemic inflammation rapidly accelerate their attrition. They burn them up. But the research here is incredible. Practices like loving-kindness meditation actively buffer the shortening. And in 3-month intensive retreats, scientists actually measured a definitive increase in the activity of telomerase. That is the exact enzyme responsible for repairing and rebuilding our biology at the cellular level.
And these are the psychological mediators that drive those cellular upgrades. By cultivating a sense of perceived control, significantly decreasing neuroticism, and fostering a deep sense of purpose in life, we are directly altering the chemistry that preserves our cells. It's not magic, it's a measurable biological mechanism. Your psychological state translates seamlessly into your microscopic biology.
I want to leave you with this thought to ponder. Because every single time we choose to regulate our waking nervous system, we aren't just earning a better, deeper, more restorative night's sleep tonight. We are actively protecting our DNA, optimizing our health span, and building resilience for the decades to come. Thank you so much for joining me on this deep dive into the fascinating biology of rest, resilience, and sleep architecture.